All right, so again, thank you very much for having me at the Singapore Java User Group. I'm here to tell you a little bit about containers, right? And well, because probably you are a Java developer, probably using a Spring or a Spring Boot as well, and you're used to package your applications as jar files or WAR files. And when we package the application as a jar file, we probably send this application to the DevOps team, which well, they basically run. So they have to gather the dependencies. They might have gather things like a GRE, right, or maybe a servlet container, or also probably they pass some parameters to your application. And that leads to the works of my machine kind of thing, right? Because, well, the application works in your machine, but probably in another environment, you don't have the required dependencies, or you're running in a completely different environment. And that's not ideal, right? So what we want is to run the application in an environment which is really close to what we have in development, right? So development and production should be quite similar. And that's why probably a container might be a good idea, because in a container, we have everything we need to run our application. That includes the OS file system, the application file system, things like how to run the application, the parameters that we have to pass to the application. So we can take this container and run it anywhere, right, in the same way. So you can just build the container yourself and send it to the DevOps team, and they will just need to run this container. But that means that you now need to create this container. And well, creating a container might seem a really easy thing, right? But you'll see that you'll have a lot of power when you create this container. The easiest way to create a container is by creating a Dockerfile. Right? So that's basically the easiest way to get started. And well, you might say, well, I have this couple of lines here in our Dockerfile, and this gets me a container. Right, so that will create a container. But is this container the most optimal container for you and for your application? So if we take a look at this Dockerfile, so what we do is to basically take a base image coming from OpenJDK, and as the name implies, this will kind of give us a GRE, right, on Java 11. And then we just take the jar file from our Spring Boot application, we just copy it inside the container, and we define how to execute that application with java-jar and the application. Well, now you have a container, so we could stop here at our presentation. You have everything you need inside a container. But things are not as easy as we have seen. Actually, in that Docker file, you can do whatever you want. You can copy stuff, you can download things, you can do whatever you want. You have a lot of power. But we know that with a lot of power comes a lot of responsibility. So you have to be responsible for a lot of things. For instance, well, the first thing that could come into your mind is which base image we should use. And the base image implies a bunch of things, right? So it implies the operating system that you'll be running on. It also implies the Java distribution, whether you want to also use a JDK or a GRE, the Java version as well. Right? Do you want to run on Java 8, Java 11, Java 14? Right? So this is basically the first question that comes into your mind. So we take a look at the container that the previous Docker file will create, and we inspect it by calling Docker history. Right? So that will basically tell you a little bit about the layers inside the container, because a container has a bunch of layers. So you'll have the layers from the base image. Usually these are read-only layers. And as we see here in our Docker history, the first layers are going to belong to Ubuntu Bionic, right? So which is 18.04. So this is basically the operating system layers. So it's basically contributing some of the operating system layers. On top of that, we have the layers contributed by the GRE hotspot. So that will basically provide the GRE to your container. And after that, you will see that your layers will be added on top of those base images, or on top of these base layers. So if we take a look at the Docker file that we have created, every single line will transform in a single layer. So notice that, well, we have the from that basically contributes the GRE, but then the args target jar is actually its own layer. The copy is another layer, and the entry point is another layer. So let's take a look at the copy one. Right? So you'll see here that we have copied the entire jar. Right? So that's actually 18 megs. And in Docker, you can actually reuse layers which are below you. That means that if you change anything in your application with that particular Docker file, you'll have to rebuild the jar file and recreate the container and replace the whole layer. Right? So you'll have to change the entire layer because your application is a single deployment unit. It's a jar file. This might not be ideal because probably most of the mecs here in this jar file are going to be like libraries. So things that you'll be using which don't change. So you'll be changing your code, but you won't change the Spring version, for instance. So we can do better by layering a little bit more this Docker container. And if we layer the Docker container a little bit more, what we'll achieve is basically faster builds because we don't have to copy, right, the entire application anymore. And also when you deploy this or you push the application into a container registry, you'll only have to push the layers that have changed. If those layers are smaller, this is going to be much faster. So in terms of bandwidth, we're going to save a lot of it. So I'm going to introduce some of the features in Spring Boot 2.3. And in Spring Boot, we have a Maven and a Gradle plugin, which basically creates the artifact, right? So here we have on the left-hand side, the Spring Boot Maven plugin, which allows you to create a jar file or a war file. So basically creates this Uber jar. But now in Spring Boot 2.3, what we can do is to enable a layered jar, right? So we are going to pass this layers enabled equals true parameter. And this will create an index for the layers that we have in our application. So if we take a look at the content of the jar file, now that we use a layer jar, you'll see a file under boot-inf layers idx. That's the index. And this will tell you the layers that you will find in our jar. Right? So we have a layer for the dependencies, we have a layer for the loader, we have a layer for the snapshot dependencies, and we have a layer for the application itself. So now we have layered our jar. When we have our jar layered, what we can do is to basically copy these different layers in its own, or the different parts of the application in its own layer. And here's a more advanced Dockerfile where we use multi-build, right, or multi-step Docker file. So the first part is basically getting a base image from the Adopt OpenJDK, so 11 GRE hotspot, and this is only to extract the layers from our jar. So basically, we're going to explode the jar and extract the layers. So this first part of the Dockerfile serves just as the builder. So we're going to just forget about this part of the Dockerfile, this base image, and our container will be created from this other base image where we also extend from the base 11 GRB hotspot base image, and we're copying some of the files from the builder, which is what we have created previously. So we basically extracted the layers, and we're copying those layers in its own, or those parts of the application in its own layer in our container. And then we're basically changing the entry point to use the jar launcher, which might be better than using Java -jar. So that's basically what you could do, right, in Spring Boot 2.3. But if you're not in Spring Boot 2.3, you can still use it. You'll have to basically split your application, copy the different parts of the application into different layers, and you'll end up in a much better Docker file. So now, if you change just one part of the application, you won't have to push, right, all the layers to the remote repository or to build the container. You'll just have to take care of the layer that has changed. But you have to take care of more than this. By default, when you create a container, you'll be running as a root user, right? And we know that running things as a root user is not ideal. So you should take care of that as well inside your container. Containers are not VMs, they are not security boundaries. So you should run as a non-user and as a non-root user. You have to understand how the build cache works. You have to also understand how the multi-stage build works, like we have seen before. You'll also have to be aware of tags. You have to also be aware of memory allocation. How much memory do you need in your container? And many other things. So you can find some of the best practices on docker.com. So if you go to docker.com, we have an article on some of the best practices that will tell you how to build a Dockerfile, right, in a proper way. If you go to Google Cloud, they will also have their own best practices. So as you see, we have to take care of a lot of things inside this Dockerfile. So creating an efficient Dockerfile is not trivial. Right? So you'll have to take care of the base image. You'll have to take care of multi-stage build, the user. Maybe you want to trim down the GRE. Maybe, well, you have to do a lot of stuff. But, well, we are Java developers, right? And for instance, for myself, I don't want to spend time on creating those containers, on creating Docker files with the best practices. Is there any way we can get those containers created, but having the best practices that we have seen? Well, one option you have is Jeep. So Jeep allows you to create a container without any Docker file. So you have here the URL container, Google Container Tools Jeep. This is basically a tool that has a Maven and a Gradle plugin. You can add it into your Spring Boot application, and it will create the container for you. It will use the distroless base image by default. You can change that, right? But this will basically be the base image. And it will also split the application into multiple layers, at least, right? Layers for the application, for the dependency, and for the resources. It will also push the image into a remote registry or into a container registry. Right? So usually the way we expose this container is by pushing that into a registry. This could be Docker Hub, this could be a local registry, this could be the registry from Google, from AWS, so any kind of registry. Right? And the interesting thing about Jeep is that it can create the Docker container without a Docker daemon, which makes it really a good fit for CI/CD kind of environments where you don't have a Docker daemon in place. And the version 2.4 just came out last day, right? And it has also an extension framework. So if you see that Jeep is not enough and you want to provide some extra behavior, right, you can use the extension framework to extend it, right, with your own needs. So this is actually one option to use Jeep for the container. So you'll get a well-defined container with the best practices and so on, right? Another option would be Buildpacks. And if you have used Cloud Foundry back in the days or Heroku, maybe the name Buildpacks, right, is already familiar to you. Right? But in 2018, right, the cloud-native Buildpacks, right, were created. So that was an initiative, right, to standardize kind of the way we created those containers. And you can find the spec on buildpacks.io. So if you go to buildpacks.io, you'll see that buildpacks.io is just a spec. Right? So it doesn't have any implementation on the specs that it defines. But the main goal is to end up having an OCI container out of no Docker file. So basically with zero configuration, we want to get an OCI image. And we have multiple implementations of the spec. We have implementations coming from Google, from Heroku, from Cloud Foundry. We have also an implementation called Paketo, which is what we're going to use today. Right? But of course, every platform has its own needs. So that's why we have different implementations of the Buildpacks specification. Right? But the main goal here is to basically have or end up having containers which are fast to build, which have reusable layers, and also that are reproducible. So if you recreate the same image multiple times, you should end up having the same container. Right? So the same input will lead to the same output. Right? So we want to be kind of deterministic here. So we take a look at the Paketo Buildpacks. Right? So this is basically what we're going to use today. So that's one of the implementations provided by the Cloud Foundry team, right, back in the day. So Cloud Foundry, we had a bunch of Buildpacks, right? So now we are basically taking those Buildpacks to outside the platform so you can use them on your maybe a local development machine, so anywhere else to build your containers. So Paketo will have a bunch of Buildpacks. If you take a look at the Java Buildpacks, you'll see that we have Buildpacks that will do a lot of things for you. For instance, if you want to use Tomcat, this Buildpack will contribute Tomcat to you. If you want to use Spring Boot, this will do something for you as well. For instance, if you want to use a GRE, you can use the Liberica Buildpack, for instance, to get a GRE in your container. So we have a bunch of build packs available here, and we'll see how they work within our environment. So let's do a quick demo on how to build our containers. And I have a really simple application here. It's not relevant for the purpose of the demo, but this is just a Spring Boot application. It's using the latest version of a Spring Boot to the 3.1, and it's basically exposing a REST controller that says hi from an endpoint. So let's start and create a container out of it. So I have created a Dockerfile. Let me just quickly get into that. This is the Dockerfile that we have seen in the slides. So we can actually create a Docker container out of this Dockerfile. That's what we're going to see first. Right? So we're going to first package the application. So this will create my jar file, the jar file that we need to build this container, because the Dockerfile is not compiling my application. We could do that, right? But it's not doing it. So I'll have to create the jar file first, and then I'm going to create the container. So it's basically compiling, passing the test. Lovely. And hopefully in the target directory, we'll have our jar file, which is this one here. So now we can build a Docker container. So we can pass that. We can define a tag. Let's call it, I don't know, Spring Boot SG. And we should go to the previous directory. So I think that this is it. Okay. So hopefully this will get the Dockerfile from the previous directory, because that's where we had the Dockerfile. And it will start creating the Dockerfile. Great. So now if I do Docker images and I grab some more, actually the one that we have created is this one here. And we could inspect it, history. And we'll see that, well, we have what we have seen. Right? So we are going to see that the different commands in our Dockerfile will translate into those layers. So now we can just run it, -p 8080, and we take the image itself, which is this one here. And this should run our Docker container. Start running. So we go to localhost 8080. Or is it running? Maybe I just have a typo here. I didn't export the port correctly. That would be the easiest way to get a container, right? A Spring Boot container. All right, so we have here hi from Docker Singapore. That's great. So now what we have to do is to push that into a container. Right? So I have here a local Kubernetes cluster and also a local registry. I'm using Kind for that. Right? So Kind allows you to create a Kubernetes cluster out of Docker containers, so you don't need much. And this is great to run locally and start your Kubernetes cluster locally. But now we'll have to push this application into the registry. So I'm going to curl the registry for a second. So we have actually a bunch of repositories already in the registry, but the way to push the image to the registry is basically doing Docker push, right, and then pushing that into the registry. Right? So I'm going to skip that. Right? So as we have a bunch of images already in the repository, I'm going to move into the next step, which is basically taking a look at the layers. So we take a look at the jar file that has been created. Let me see that. So what we can do is to basically inspect the layers that we have in here. So we have here a list command that will tell you the different layers that we have in the jar files. As we see here, we have a bunch of layers, which are created by Spring Boot. So remember that when you use the Maven plugin with layers enabled, this will create an index file that will create the layers for you. So by using the list command, you can see the different layers that your application has. You can, of course, create new layers if you want. And if you use extract, you'll be able to extract those layers. And in this Dockerfile, which is the one that we have seen in the slides, I'm basically using the extract command to extract all these layers and then build the different layers right in our container. But again, enough of Docker files, because as we are Java developers who maybe you're not interested in building the Dockerfile yourself. So I'm going to use Jeep now in order to create the Dockerfile. So I'm going to do Maven compile, and I'm going to use the Jeep Docker build command. So if we take a look at the POM file, I have added Jeep into it. So let's scroll down. So I have the Jeep plugin, which will create a container for me, and it's going to push it directly to my local registry. So localhost 5000 / Spring Boot SG Jeep is going to be my container name, right? So this will push into my local registry just by using Jeep Docker build. So let's try to create a Docker file with no, a Docker container with no Docker file. As we see here, we're using the Maven plugin for Docker. So notice that we're using the distroless base image, as we don't have any Docker file. So Jeep will choose the base image for us, right? So you could change that, but this is already chosen for us. And it's also splitting the application into multiple layers. So now what we can do is to take a look at the build container. So this is basically the build container. And a really nice tool to dive into the container and see the different layers that we have in our container is dive. So you can do dive and the name of the container, and this will give you like a pre-visualization of what's inside the container, which is really, really nice. So on the right-hand side, as we see here, we have the different images or different layers of our image. So we're going to focus on the 3 last layers. So these 3 last layers are nothing more than our application. Notice that this layer that I have selected is adding the libraries of our application. So on the right-hand side, you can see this in red. So it's basically adding these libraries, which are 18 megabytes. So this is usually what will never change in your application. You'll probably change your code, but maybe you won't be changing your libraries. So that's why this is in a lower layer than your application code. But if you take a look at the second layer, which are some bytes, these are just the resources. So for instance, the application properties that you have in your application. So it's contributing this part of the image, which are the resources. And the last layer is contributing your code, right? So these are the application classes here, right? So this is the code that you have. Great. So we have classes, libraries, and resources in different layers. So let's do one thing now. Let's go back to our application and let's change something. Right? So let's change our class, and let's say, well, I want to show hi from Docker Singapore Jeep. And I'm going to build the application again. Right? So I'm going to use Maven compile Jeep Docker. So I'm going to compile it again. And hopefully this will reuse my existing layers, because we don't have to change anything. We just need to change the layer for our application. And this will create yet another container. So let's compare these 2 containers now. Let's make it a little bit bigger. Hopefully this will fit in one slide. Okay, great. All right, so let's dive into the new container. And we'll compare the hashes of every single layer, right? So every single layer has a hash, so we know whether we can reuse it or not. And let's take a look at the 3 layers that we have seen. And now we're going to take a look at this hash here. This is the hash of the container, or of the layer. So let's compare that with the other container. So we take a look at the hash of that layer. We see that it's the same, right, in both containers. Both containers have the same layer. That means that this has been cached and they both use the same layers. Right? It's actually great because these are the dependencies. These haven't changed. So we could reuse that layer from the cache. What about the resources? Let's take a look at the resources. The resources has this hash down here. So let's take a look at the hash from the second container, the new container, and we see that they are both the same. So we have reused the resources as well. But what about the last layer, which is our application? So our application has changed. So we take a look at the hashes from both containers, we see that they are now not the same. So this hash starts with 29.8, this other hash starts with FDF. So the container just differs on the last layer, the topmost layer. And notice that it's only 3.5 kilobytes. That means that if you want to push that into the registry, which we have done with chip, we have just pushed these 3.5 kilobytes. We haven't pushed the entire image, which is great, right? Because this leads to faster builds, this leads to less bandwidth. So when you're developing, this is really important, right? So that's basically what we achieve by layering the container. Lovely, that was a JIT, right? And basically we compared the different digests or different hashes from the containers. So the other alternative that we have seen was basically the Buildpacks. And in Spring Boot 2.3, we have really nice integration with Buildpacks. And by default, we're going to use the Paketo Buildpacks. So how can we create a container, right, from the Buildpacks? So we have a command which is Maven Spring Boot build image. You can define your image name, right, which will be localhost 5000 Spring Boot SG. And when I do that, we're going to use Buildpacks to create the container. Let's see what happens when we create those containers. Well, first thing that will happen is, of course, building the application, compiling it, passing the test. So that's a normal Maven build, right? But after that, when everything is generated, we have our jar file. So notice that we have here our jar file. We're going to start creating the Buildpack the container. In Buildpacks, right, that we don't have the concept of a base image. We have the concept of a builder, right? So you'll see that we'll be using a builder, which is by default a base platform API 0.3, and it comes from the Paketo Buildpacks. When you create a container, more than one Buildpack can interact or actually participate in that creation of the Buildpack. In our case, we see that we have 5 Buildpacks that will be participating when creating this particular container out of 15, right? So we're basically creating what's called a build plan, and the build plan will define which build packs are going to participate in the creation of the container. So we see that we have something called Bells of Liberica. This is basically a GRE or Java distribution. We have another build pack that will take care of the executable jar, Apache Tomcat, this is it, and a Spring Boot. Great. So, well, seems that I have run these before already, so I probably will get a bunch of layers from the cache. But let's take a look at the different build packs. The first build pack that kicks in is the Paketo Bells of Liberica build pack. Notice that this will contribute, in our case, a GRE. And it will contribute a GRE, which will be a GRE 11, right? So depending on what you expect, this could contribute a JDK or a GRE. Of course, having a JDK in production or in a container might not be a good idea, right? So apart from being, or the container being bigger in size, this is not a good idea, right, in a container. So probably you'll need a GRE to run your application. But along with the GRE, it will start contributing a lot of layers. For instance, the memory calculator. Memory calculator is quite interesting because it will calculate the amount of memory that your container requires, right, based on a bunch of things like the number of threads, number of classes that you have. So when you start the container, the first thing that you will see is the memory calculator kicking in. We have another layer, layer contributed, which will be the class counter. We have another layer, which is the JVM kill, because when you run out of memory, your process might be in an inconsistent state. So the JVM kill will be an agent that will take care of killing your process so it can be recreated by Kubernetes, for instance. We have the local DNS, so that's basically a local DNS because, well, the JVM, when it resolves an address, it caches that address forever, right? So this will basically have a local DNS, so you can interact with resources that or change the IP frequently, like in Kubernetes, right? Where we have different pods, different resources that change the IP frequently, and you don't want to cache those resources. We have also Java security properties and basically certificates. So you'll see that we have a bunch of layers added to the container. that will give you a lot for free, right? So if we compare that to the first Docker file that we have created, that Docker file didn't have anything. So it lacked a lot of things, right? And another thing that the Buildpacks will do is to create a user. So you'll be running your container on another user, which is not the root user. So we have a GRE. So now we have this executable jar Buildpack that will add the entry point, right? So that's basically how we're going to execute the jar file. We have other Buildpacks that will contribute also, for instance, the Spring Boot Buildpack and many other Buildpacks. And notice that all of them will basically contribute in different layers in our container, right? So we're going to see that in a second. And eventually, we'll get our image created, which is this one here. So let's take a look at the image that we have created with Dive. Right? So as mentioned, Dive is a really nice tool to inspect the image. And so we're going to use Dive, and we'll see the different images that we have, different layers that we have in our container. Great. So I'm going to jump directly into some of these layers. Let me just change the filters here and just filters, and I don't want the unmodified. Okay, now, so let's take a look at this one here, right? So this is basically the layer where we see that the Buildpack adds something into it, right? So this is basically something related to the life cycle, but eventually you'll see that the Buildpack already contributes on some layers. So this is the class counter. This is basically the Java security properties. This is the GRE. So notice the size of it. So 140 is basically the entire GRE. Then we have another layer which contributes the JVM kill agent, as we have mentioned, another layer that will contribute the local DNS, another layer that will contribute the memory calculator, and so on and so forth, until the last layers, which basically use the layer jar that we have seen to split our code into different layers. So notice this layer is 18 megs, and it basically contains the libraries of our application. Then we have another layer which basically has the boot loader. We have another layer which has our container, our code, right? So basically we have everything layered in its own layer, as we have seen in the jar file, which is really nice, right? So at the end of the day, we'll end up having a container with high standards. We have a container which has like multiple layers for our application, but also contributes or has a bunch of things that will make our container up and ready, right, for native or cloud native deployment, which is really, really nice. All right, so far, so good. Right, so now we have our container. Now that we know how to build a container, different ways to build a container. Of course, Jeep and Buildpacks are doing a great job building those containers, but sometimes we need to go back to Dockerfile. So Dockerfiles are really, really flexible, right? So if sometimes you might need more flexibility, and Dockerfiles are also an option. So Buildpacks are not a replacement of Dockerfile sometimes, right? So it's really nice ways to get the container done or created. But sometimes if you need more power, you can go back to the Dockerfiles, but you'll have to take care of everything that we have mentioned before. Great, so now you have the container, right? So you're ready to distribute that container. So hopefully you have pushed the container to a registry, and now we can run this container somewhere. You could use Docker run, right? So you could run your container, right? So just locally, we could do that. But probably in production, you will need some kind of orchestration, right? So you will need to observe your containers, to check whether they're available, whether you want to scale those containers, the application, you want to have some operability and maintainability, and many other things. Right? So just running your container, maybe with Docker Compose or any other tool, won't be enough. Right? So when you go to production, maybe you need some kind of a container orchestrator, and this could be Kubernetes in our case. Right? So, well, the premises of Kubernetes are really nice. So you get a platform where you deploy the application. It's going to be constantly monitored, and the platform will restart the pods or the containers that are not alive, and so on. But when you get into Kubernetes, well, someone will tell you that Kubernetes is great, but of course it has a learning curve, right? So, well, you basically see a lot of articles on the internet telling you that Kubernetes is great, it's easy to get started, and then when you get into Kubernetes, you'll see that, well, you have to understand a lot of things like what a config map is, what a deployment is, what a service is, what are the what is RBAC or the persistent volumes or many other things. Right? So it has a learning curve as well. So I'm not going to try to tell you what Kubernetes is, but at least I'll tell you a little bit about the bits and bytes that we'll need to push our application into Kubernetes. So far, we have what we see here. We have a container where we have our application, probably we have layered our application, and we have pushed our container into a container registry. As mentioned, this could be Docker Hub or any other container registry which is out there. But in Kubernetes, we cannot simply deploy a container. So the smallest unit of deployment is a pod. A pod will contain your application, your container. Actually, in a pod, we can run multiple containers, right? But usually we have a one-to-one mapping between your application and a pod, right? So again, you can have multiple containers, but this is going to be the deployment unit and the scaling unit as well. So if you want to scale, you'll be scaling a pod, an entire pod. That's why, well, having things like a database inside the same pod as your application might not be a good idea, right? Because when you scale your application, you'll be scaling the database as well. So you usually have this one-to-one mapping into the pod. But this container, right, or this pod needs to be replicated. At the end of the day, having a single instance of the application won't be enough in production. So we'll be creating a replica set, and the replica set allows us to define the replication of the application. You can decide, well, I need 3 instances of the application, so the replication will be 3 in our case. And this will take care of our containers, our pods. It will basically check that the current state is the same as the desired state. If we mention that we wanted 3 instances of the application, and there are only 2, Kubernetes or the platform will automatically create an extra pod for you, an extra instance of the application for you. So it will make sure that you always have the number of replicas that you need. But rarely you'll be creating a replica set by its own, right? Or a pod by its own. So you never create a pod by its own, and it's rare you can do it. Right? But usually what we create is a deployment. And when we talk about pods or replica sets or deployments in Kubernetes, that translates into a YAML file. Right? So we have to go back to writing some files. So in Docker, we have avoided writing these Docker files, right, by using Jeep or Buildpacks. But now we have to go back to YAML and create the pod definition or the replica set definition or a deployment definition. So usually we'll be creating a deployment definition that will define the number of replicas of your pod, and it will define also the containers in those pods. So the base, the images in the registry, and so on. Great, but now when we have the pods up and running, those pods are not going to be visible outside. So they're going to be local inside the cluster. But if you want to make them visible to the outside, you need to define a service. We have different types of services, right? If you deploy that into a Kubernetes provider like a GKE, right? This could be a load balancer. Or locally, this could be simply an exposure of, or basically defining an IP that will expose those pods. So service is nothing more than a way to access your pods, because by default they will be internal and you won't be able to access them. So we need to create a service to interact with those pods. Great. So in Spring Boot 2.3, we have something called the liveness, or actually the concept, or also in Kubernetes, we have the concept of liveness. And what do we call that? A pod is alive, right? So basically, when the internal state of that pod of the application is valid, right? So we basically started the application, everything is valid, and we can basically say that the application is up and running, right? So when the aliveness test or prop says, well, we are not alive, so something wrong is in the application, what Kubernetes will try to do is to restart the container. So the liveness test or the probe basically says, well, can we restart the container and get an application live and in a valid state? And so basically, it answers this question. If restarting the pod or the container will solve the problem, then just say, well, I'm not alive, right? And in this aliveness probe or actually check, you usually don't interact with external resources, right? Because let's imagine that you have a health check against a database and you make this part of your liveness check. What will happen is that if your application is up and running and your database is down, Kubernetes will try to restart your container. But this can deal to cascading failures, because if you have more than one instance of your application, this will start restarting all the pods, all the containers that you have, just because your database is down. So usually that's something that we check without external systems. And in Spring Boot to the 3, we have an endpoint to check for the liveness of the application. So back in the days when we didn't have a Spring Boot to the 3, we usually set the liveness probe to /actuator/info. But now we have a specific endpoint for that called actuator health liveness. We have another concept, which is the readiness. So you could be up and running, but maybe you're not ready to accept traffic. So let's imagine that your application is up and running, but you are building the cache, maybe from another resource. So while you're building the cache, your application is not ready to accept traffic. So when you're not ready to accept traffic, your application will be removed from the services. So no traffic will be routed to your applications. Right? So you have to be real careful on what you define here in the readiness check, right, or probe. We have some recommendations, but at the end of the day, it's basically you that you define what makes your application ready, right? But at the end of the day, this needs to be something that you define, right? And we'll see that in a second. So in Spring Boot 3, as we have the concept of liveness and readiness inside the application, we have a couple of components that will be part of your application context that you can use to change the liveness and the readiness state. We have a couple of objects called readiness state and liveness state, and by injecting or getting an instance of the application availability, right, which is already in your application context, you'll be able to check the liveness state and the readiness state. If you want to change the liveness state and the readiness state inside your application, what you can do is to emit an event. At the end of the day, when something happens in your application, let's say, well, I'm building the cache, you only know when the cache is ready or when we have ended building this cache. So at this point, you can send an application event and change the state of the application from unready to ready. And you can do that with this availability change event. So let's take a look at it in a second. So if I have here a cluster, let me just log into the cluster with this token. I have here my local cluster, right, which doesn't have much. We see here that we don't have any deployments, we don't have any pods, we don't have any replica sets. And what we're going to do now is to basically take the Docker container that we have created and push it into Kubernetes. So for that, what we'll be creating is basically a deployment. Let's go back to our terminal. And I'm going to create a folder called Kubernetes, just forgot the S, but anyway. And I'm going to check the registry first, and let's see what we have in there. Let's see what we have here, curl, catalog. All right, so we have a bunch of containers. So I'm going to push one of these containers directly into Kubernetes by creating what we call a deployment. A deployment is nothing more than a YAML file, but as mentioned, we might not be willing to create a YAML file. So what we're going to do is to use the kubectl command, or kubectl, or kubecontrol, however you call it, to create a deployment, right, implicitly, right, or interactively, without having to create a YAML file. We can do it by using the kubectl create deployment. I'm going to specify the name of the deployment as Spring Boot SG, and the image of the deployment, which I'm going to choose localhost 500 Spring Boot SG Buildpack. And notice how I'm using this -o YAML. So that basically generates the output YAML as a YAML file. And I'm going to use this dry run. Dry run simulates the creation of the deployment. It's not sending that into our Kubernetes cluster. It's basically simulating that we create that deployment. So that is what this will do, is to generate the YAML file corresponding to a deployment. And I'm going to pipe it to deployment.yaml. Great. So hopefully we have the deployment created. So let's take a look at the deployment.yaml. So that's basically my deployment. So we see the name of the deployment. We see a label. We see the replicas as well. So by default, we get one replica of the application. And we see the container that we're going to push into one of these pods. So now that we have the YAML file, what we can do is to kubectl apply -f, and we pass the deployment.yaml. If we take a look at our cluster, let's put it here, and we deploy that, we'll see that the pods will be created. So notice that by deploying or applying the deployment, we have a deployment created, but also a pod created and a replica set created, right? So remember, right? So a pod is basically the smallest unit of deployment, but we have to define how many replicas we want, and we also define the deployment. So now we have one pod, and as we see here, well, this is basically having our container. This is running our application internally. And what we could do is to change the deployment. So I'm going to change the deployment and say, well, I need more than one replica. Or I want 3 replicas. I'm going to deploy that or apply that. -f deployment.yaml. Let's just move to here for a second. Let's apply that and let's see what happens. So here we have 1 out of 1, but notice that automatically this will create 2 other pods, right? And it will basically start our application. Now we have 3 different pods containing our application, but these pods are internal. We cannot access them, as mentioned before. Right? So we need to create a service from it. Great. Another thing we can do, just real quick, is to try to kill one of these pods. Let's say I want to kill one of these pods, and just because we have the replica set, we have to see this pod being recreated. So I'm going to delete this resource from here. I'm going to quickly move into the overview, and we'll see that, well, we have 2 out of 3 pods, and these will automatically delete the pod that from our cluster, and then deploy the new one. Right? So yeah, so now we have the 3 of them up and running. So we have detected that one of them was deleted, but we needed 3 pods. So we have recreated a new pod. Lovely. So now let's get into creating the service. So we're going to use the same approach. We'll be creating the service implicitly without creating a YAML file. And we'll do kubectl create service. And we have different types of services. We'll create a service of type cluster IP that will create basically an IP, right, inside our cluster, right, to basically interact with our pods. But this could be a load balancer if you run within a GKE or any other platform. And we're going to, again, right, so generate the YAML, and we'll do a dry run. So that means we're not going to send it to the Kubernetes cluster. We'll basically simulate that and send it to a service called a file called service.yaml. All right, so now we have our service, and the service looks like this. So it's basically getting access to our pods. So we'll need to apply ctl apply -f service. We need to apply the service. Let's take a look at the services real quick. And when we apply this service, we'll see the service being created here. That's our created service. And notice how it basically has, right, the 3 pods accessible. So that means that if you use the IP of the service, we'll be able to access one of these pods or any of these pods. But as we are locally, what we need to do is to forward the ports from our host machine into the ports of our service. And we're going to do a port forwarding for that. Just let me open a new terminal. So we're going to do port forwarding for that. So we're going to do kubectl port forward service Spring Boot, and we're going to map 8080 to the port 80. So hopefully, let me check. Too many windows here, tabs. Let me check the name of the service. Service was called Spring Boot SG. So this needs to match the service. Okay, so hopefully the port forward will work now. And when we access here on our machine, localhost 8080, so this should actually get into one of the pods. And so when we hit that, we are actually getting to one of the pods in our Kubernetes cluster. All right, so let's take a look at the liveness and the readiness probes. In Spring Boot 2.3, as mentioned, we have 2 special endpoints that we can configure to basically define what is an alive application and a ready application. So if you use this management.health.probes.enable equals true, you'll enable those couple of endpoints. If you deploy that into Kubernetes, these are already enabled for you, but if not, you can explicitly enable them by using this property. Remember that we can change the readiness and the liveness by using something called the application event publisher. So I have here a class which is nothing more than a REST controller, which is exposing a port, an endpoint called change readiness. So the only thing that this will do is to get the current state. So it will check the current readiness state. Notice that I'm going to use the application availability, which is already in the application context. I'm taking it, I'm checking the readiness state. And if this is equals to application accepting traffic, I'm going to change it to refusing traffic. And I'm going to publish this event. So by just publishing this event, we're going to change from a ready state to a non-ready state. And that will make our pod available, but it won't get new traffic into it, which is quite interesting. So what do we need to configure the props, right? The readiness and the liveness props in our Kubernetes cluster or deployment. So we'll be, let's see if I will see it here. I'm going to go to the deployment, and I'm going to add a couple of properties, right, which are the readiness and the liveness. Here you go. So I'm going to set the readiness to actuator/health/readiness and the liveness to actuator/health/liveness. I have changed my deployment, so I'm going to basically apply this deployment real quick. kubectl apply -f deployment, and hopefully that has changed my pods. Okay, so let's wait a little bit. May have something wrong here. Might take some time. I'm not sure if I did it right, because that should be already up and running. But apparently I did something wrong in my deployment probably. It's probably something wrong in the indenting of this. Check that. So Michael, how are we doing with time?
I think it's okay, but there are like quite a few questions for you as well.
Okay, so maybe we can move on and leave some time for questions.
Yeah, if you want to look into the chat.
Okay, just a couple of slides. Another thing that Spring Boot 2.3 introduces is the graceful shutdown. So at the end of the day, if you have ongoing requests and you say, I want to terminate the pod, you cannot leave those requests unprocessed, right? So you want to finish with those requests and then terminate your application. And this is called graceful shutdown. At that point, you don't want to accept new requests, but you want to wait until everything has finished, right? And that's basically the graceful shutdown, which you can enable in Spring Boot 2.3 with server.shutdown graceful. And additionally, you can define how many seconds you want for a grace period. That works for all the servlet containers, both for the servlet stack and the reactive stack. So you'll see that when you terminate your pod, the pod won't be killed. You'll have the grace period to terminate or to finish with the requests, and then your pod will terminate, right? So that's really nice. So you don't have ongoing requests, right, unprocessed. And last thing I wanted to show you, but we didn't have time to do it. At the end of the day, when you are developing, you basically go through this build, deploy, refactor kind of cycle. You build your application, you have to, or actually you change your application, you build your container, you push it into a registry, and then you have to deploy it into Kubernetes, right? And this takes some time, and you have to maybe apply or create the container, apply the deployment again, and many other things. So what you can do to be faster, well, the point is to use a scaffold. The scaffold allows you to monitor your source code. So when you change the source code, it will automatically compile the source code, create the image for you, deploy it into Kubernetes, and you can see the application up and running into your Kubernetes cluster. So this will simplify a lot, right, your development for sure. But you can also use a scaffold for your production environment, not only for development. So if you have liked what you have seen today, right, I recommend you to check out these couple of workshops, right? So a really good workshop from Ryan Baxter and Dave Sire on Spring and Kubernetes. This contains a bunch of the things that we have seen today, right? So how to create the applications with Buildpacks, the containers with Buildpacks, how to deploy that into Kubernetes, the liveness prop, the readiness prop, and all this stuff, scaffold, and customize, and many other tools. Actually, the Kubernetes environment is huge, right? So we have a lot of stuff. So it is actually a really nice workshop to follow. And then we have another one by Dave Sire as well, called Kubernetes Intro, which is also exposing or telling you a little bit about all these things, right? So they're really similar, but I would recommend you to follow both of them. They're really detailed, and they're great to understand how to deploy your applications into Kubernetes. And with that, I think that that's everything from my side.